stress. The tangential force per unit area is known as the shearing stress, and shearing strain we have to find out by using the diagram, this diagram. That means we have applied a tangential force on this surface, a tangential force on this surface. The shape of the body after it has changed its shape becomes like this. So a shift of angle, take it to be phi. So delta L is the change in length here. The original length on of this side is L. So delta L by L, F by A. Now area of cross section means the area of the surface on which the force is applied, and not this area. No other area, only that area on which the force has been applied. If we take a book and try to slide the book, if we can apply a tangential force onto the right side, this area is taken to be the same as this A. So F by A, delta L by L. Now if we look at this shape of delta L by L, it may look like a longitudinal strain, but longitudinal strain, the change in length was in the direction of the original length of the wire. In this case, it is along the perpendicular direction of the original length. It is along the perpendicular direction to original length, delta L by L. So don't get confused. Now we can write this expression of n in this way also. In many books you can find in this way, by phi, not by delta L by L. F by A by the angle. Shearing strain means the angle of change. Now if we can write the statement of tan phi from this diagram, we can write it delta L by L. Tan phi means perpendicular by base. Now if phi is very small, phi is in radian and very small, what happens? Tan phi becomes equal to phi, delta L by L. So the replacement of the value of phi as delta L by L has been done here in this way. So you can write the statement at first in this way, F by A by phi, and then after showing this you can state it like F by A delta L by L. The fourth modulus is Poisson's ratio. The pronunciation is Poisson and not Poisson. Till now we have studied three types of modulus. All three have been modulus of elasticity, that means stress by strain. This is the first modulus, which is a ratio of two strains. It is a ratio of two strains. Poisson ratio denoted by the small sigma. So small sigma is equal to, we have to write on as numerator lateral strain by longitudinal strain. Lateral strain by longitudinal strain. That means if we can draw the diagram like this, if we take a wire or a thick cylindrical soft thing like this, if we can apply a force on it in this way, in this direction, the body will have a constant volume, but it will look like this. So if you are applying a stretching force or a pulling force, the radius or the diameter decreases and there is an increase in the direction of the length. Here the volume remains constant. Volume is constant. Only there is a change in shape. Now if the original diameter was d, original diameter was d, that means this diameter was d, but this diameter is d minus small d. That means the change in the length of the diameter is small d, this part plus this part. So sigma is equal to lateral strain means d by d. This is the lateral strain. Why lateral? Because we have applied the force in this direction, so change perpendicular to it will be named as lateral strain, and the change in the direction of the force will be named as the longitudinal strain. So the normal or the 90-degree expansion for this one was d by d. D is the change in length and original diameter was d by you can write it delta L by L. Now what is delta L? This amount is delta L, change in length by the original length L. So delta L by L. So this is the expression for Poisson ratio. You can write the limiting values of Poisson ratio. Limiting value of Poisson ratio, that is plus half to minus 1. Plus half to minus 1, but in practical plus half to 0, because the negative part does not exist, because there cannot be an increase in length as well as an increase in the diameter at the same time. One will have to decrease for the increase of another. So the negative part, that means minus 1, minus 2, minus 3, will not be there. After 0, that means minus 0.1, minus 0.2, minus 0.3 up till minus 1. This part is non-existent. The practical existent values is half to 0.